ever wonder what makes a hot air balloon fly? Well, I'm here to explain Charles' Law, which will make you better understand it. I'm also going to explain another closely related concept known as absolute zero. Let's begin with Charles' Law. Charles' Law states that if a set quantity of gas is held at a constant pressure, its volume is directly proportional to the temperature. Now what does this mean? This means that dividing one by the other gives you a constant value. It also means that as one variable increases, the other variable increases at the exact same rate. This creates a linear relationship, which you can see by this graphical representation. As the temperature increases, the volume also increases at the same rate. Let's look at a real-life situation of a direct relationship. Let's take a look at the simple direct relationship between this man's weight and the amount of food he eats. Right now this guy is very skinny, but what would happen if he were to eat increased amounts of food? Well, this could happen. The more he eats, the fatter he gets, or the more weight he gains. This is a perfect example of a direct relationship. As one variable goes up, so does the other. The temperature and volume of a gas share the same proportional quality. Let's find out why this is. Keep in mind that gases are made up of small particles that are constantly in motion. As the temperature of a gas increases, these particles increase in speed and collide more frequently. As a result, they spread out and take up more volume, if in a flexible container, such as a balloon. This relationship is what allows a hot air balloon to fly. The flame under the balloon acts as the heat source, increasing the temperature of the air, which then expands to fill the balloon and lift it off the ground as a result of the lighter spread out air inside of the balloon. This knowledge will help you understand our next topic, absolute zero. Absolute zero is the lowest theoretically possible temperature at which all particle motion stops. It's equal to negative 273 degrees Celsius or 0 degrees Kelvin. At this point, you're probably wondering where in the world we got these values. Here's how. Recall that as a gas temperature increases, its particles speed up and its volume also increases. From this, we can infer that if the gas temperature decreases, particle motion will slow, decreasing the gas's volume. So theoretically, gas particle motion could be completely stopped if brought to a low enough temperature. A man by the name of Lord Kelvin decided to explore this idea. He graphed the volume of different gases at different temperatures. He then extended his data for each different gas all the way down to a volume of 0. Amazingly, all the lines converged at a single point, negative 273.15 degrees Celsius. Lord Kelvin developed the absolute scale based upon this lower limit of temperature and gave this absolute 0 point a corresponding value of 0 degrees Kelvin. Now we can never truly attain this value because the particle motion speed of 0 corresponds to a volume of 0, which would mean the gas sample ceases to exist at all. Instead, we can only try to closely approach this value. Now let's take a more mathematical approach to discover how scientists determine the lowermost limit of temperature. This table shows various recorded temperatures and their corresponding volumes for a sample of gas. Using the points in the table, you can see that the relationship between temperature and volume is expressed by the following linear equations. Since the volume of a gas can approach 0 but can never equal or go below it, you can determine the least possible temperature by solving the limit of temperature as the volume approaches 0. Since T is equal to this expression, you solve the limit of this expression to get the limit of temperature. To solve this particular limit, you immediately direct substitute 0 for V, which gives you a value of negative 273.15 degrees Celsius, equal to 0 degrees Kelvin on the absolute scale used for gases. Although we can never reach absolute zero, we are getting closer and closer. A group of scientists at Helsinki University currently hold the record for the lowest attained temperature at 0.000000001 degrees Kelvin. We'll just have to wait and see how much closer we can get.